Okay, here we want to use the tabular method, but we want to show why the tabular method is the preferred method here over integration by parts. So now, first we can see we have a product, which is usually when we want to use integration by parts to find the antiderivative of a product. But we also see that this is raised to the third power. Therefore, if we chose integration by parts, we would have to run through the cycle 3 times. So for this reason, we want to choose the tabular method. Remember, the tabular method is a shortcut alternative to integration by parts. So we still want to use Liate, if everyone can remember. Which means we want to choose U, logarithmic, inverse, algebraic, trigonometric, exponential, those functions in that order of priority. Now, 2x cubed would be algebraic and sine 4x would be trigonometric. So of course, A comes before T. So on this left side, we're going to say U, which is going to be 2x cubed. And on the right side, we're going to use sine 4x. Now, on the left side, we want to use derivatives all the way down until we get to 0. And on the right side, antiderivatives. So the derivative of 2x cubed would be 6x squared. The derivative of 6x squared would be 12x. The derivative of 12x would be 12. And the derivative of 12, of course, is 0. I'm going to come back and put my exponents in. Now, on the right side, we want to use the antiderivatives. Now, we have to be careful right here with the positives and negative signs because any small mistake prove costly down the line. So the antiderivative of sine 4x, if we remember, is going to be negative cosine 4x over 4. The antiderivative of negative cosine 4x over 4, think about this, the antiderivative of cosine is sine, but this makes it negative sine 4x over 16. Okay, we keep moving. The antiderivative of negative sine 4x over 16 is going to be cosine 4x over 64. And then the antiderivative of cosine 4x over 64 is going to be sine 4x over 256. If we remember this is just finding the antiderivatives with the chain rule, which we can look at. Okay, now that we have these, the first thing we want to do, is cross multiply. Okay, and the second thing we want to do, we want to alternate the signs. We want to go plus, let me put it in red, minus, plus, minus, plus. Okay, now we simply want to multiply and finish the problem. So here, negative 2x cubed times cosine 4x over 4. I'm going to go ahead and reduce this. Negative x cubed over cosine 4x over 2. If we look at it, we know that 2 divided by 4 is 1/2. So we're going to put that in there. I'm going to come back and put the exponents in. All right. My next 6 over 16, that's going to reduce to 3/8. So we're going to say 3 sine 4x. Sorry, that's 3x squared sine 4x over 16. We're going to reduce that to 8. You all could do the mathematics on it. Now, 12 over 64. That's going to be 3/16, I believe. So that's 3x cosine 4x over 16. And now 12 over 256. You definitely need to reduce this one. This will be what, if we divide both sides by 6, we'll do it, let's divide it. We're doing the scratch work right here. That's going to be 3 over 64. That took longer than it should have, but that's 3 over 64. And we, as always, we want to add our arbitrary constant of integration C. Remember, this is going to be plus, this is going to be plus, and this is going to be minus. Let's put everything back in. So this is why we do the tabular method. It makes everything work a little faster and a little smoother. Now, we would have gotten the exact same answer. We've gotten the exact same answer had we done the integration by parts, but it keeps us from having to go through 3 cycles, right? So it's just a matter of efficiency when we're working these types of problems.